Okay, good day class. Alright, so the last lesson we have learned how to get the formula for the trapezium rule. Alright, how to get the formula for trapezium rule, and this is the formula for trapezium rule by construct a table and so on. Alright, so today we are going to see, the next thing that we're going to see will be the accuracy of the trapezium rule. It is similarly like Newton-Raphson method, iterative method. Okay, so we want to see how accurate the trapezium rule can give us the estimate area under the curve. Alright, so let's see. So number one, note that the approximate value obtained by using the trapezium rule can be greater or smaller than the exact value depending on the shape or the concavity of the curve. Alright, so I think you still remember when we are doing Riemann sum. Okay, so let's see. When we are doing Riemann sum method, the rectangle that we construct, okay, some might be below the curve. So the answer that we get is actually smaller than the actual area. Some will be higher than the curve. So this one will be the estimate that we get will be greater than the actual value. And the midpoint, some higher, some lower, so it gives us the better approximation. So it will be similar concept to trapezium rule. All right, but to determine this, we are talking about concavity lah. Okay, let's see one by one. Okay, the first condition is, you see from the sketching, let's say this is a curve. All right, so from the sketching, you see that the curve is actually concave downwards over the whole interval from A to B. Is concave downwards. Still remember concave downwards? Means the gradient of the curve is decreasing. See, at first it's very steep, so the gradient is bigger. Then it's getting more horizontal, see that, or less steep. So the gradient of the tangent is decreasing. So we say it is concave downwards. So you see this curve is concave downwards. Another way for us to determine concave downward is, you see the tangent that we are going to draw on the curve will be on top of the curve. Or the tangent drawn will be above the curve. Alright, so this is concave downwards. So if the curve is concave downwards, so the trapezium are each lower than the curve. So let's say I enlarge one of it. If I enlarge this part, so it will be something like this. This is a curve, but the trapezium that we are going to draw is like this. So it's actually, the trapezium draw is lower than the curve. Alright, this is a condition. So if the curve is concave downwards, then the trapezium that we are going to draw and calculate the area will be actually less than the actual one. Therefore, hence this total area is smaller than the area under the curve. It's smaller than the actual area, right? Therefore, the trapezium rule gives an approximation value which is smaller than the exact value, and we call it underestimate. All right, so make it very clear. If the curve throughout the domain that we want is concave downwards, then the trapezium drawn will be actually lower than the curve. Means that the area of the trapezium is actually smaller than the actual area that we calculate. Then we call this underestimate. Alright? Okay. Second condition is, from the sketch you see this curve is actually concave upwards. This is concave upwards. You see that the tangent that we're going to draw will be from more horizontal going to more steep. Alright? So the gradient of the tangent is increasing. Therefore, we call it concave upwards. Alright, so another way for us to determine concave upwards is, you see that if we draw the tangent on the curve, you see all the tangent drawn is actually below the curve. Alright, therefore this is concave upwards. Then the trapezium are each higher than the curve. Again, let's say we enlarge one of the trapezium. You see this one will happen. Alright, the trapezium that we drawn is actually higher than the curve. Alright, so obviously the trapezium rules give an approximate value which is greater than the exact value. All right, and we call this overestimate. Is it okay? So for the accuracy of the trapezium rule, sometimes it gives us underestimate, sometimes it gives us overestimate. All right, so a graph is necessary to show the curve is concave upwards or downwards. To determine why the approximation is smaller or greater than the exact value, means why it is overestimate or underestimate. So we need a graph. All right. So however, if the graph is sometimes concave upwards and sometimes concave downwards, or let's say this part downwards, then another part upwards. If this happens, then it becomes impossible to know if the approximation is overestimate or underestimate. Then we cannot make decision whether it's overestimate or underestimate lah. Okay. Then next, sometimes they will ask you to calculate the percentage of error. It's smaller when, sorry. Okay, no. So, what is the meaning of percentage error? Percentage error means we use the area that we calculate by using trapezium rule compared to the area that we calculate by using integration. Of course, by using integration, that one you see is an actual exact or correct answer. By using trapezium rule is estimate. So we will see the difference. Okay, then we calculate the percentage. We call this percentage error. All right, so the percentage error is smaller when more intervals are used. Means that if we cut it into more intervals or more strips, all right, then the estimate answer that we get will be closer to the actual answer. Okay, so this is the last part that we are going to discuss in this chapter. Okay, so we will discuss two examples to see what means by this part. All right, so please open your textbook, page 188. All right, we are going to see two examples, example 11 and example 12. Okay, all right, this is example 11. So it sounds like this. Evaluate tangent x from 0 to pi over 3. You can see. Okay, let me get bigger. Okay. Using the trapezium rule with ordinates, they give you these ordinates. All right. Given your answer correct to two significant figures. All right. Since the ordinates given, so we just put it in the x, then sub all this value into tangent. Of course, remember when you press a calculator, this is in radian. So either you set your calculator into radian mode or you change it to degree, okay, before you calculate tangent x. So these are the values that we get. So from here you see the question one, two significant figures, right? Therefore, all the answers that we are using is four significant figures. Or even though this one also four significant figures. All right, so by using the trapezium rule, okay, so see, we are using approximate sign. Okay, so half D. So what is your D? How to calculate D? How many ordinates? 1, 2, 3, 4, 5. 5 ordinates. Right? So your N is 4. You can calculate by using that one. So pi over 3 minus 0 over pi over 4. You can do that. Or another way is because the ordinates given. So you see each time is actually add 1 over 12 pi. Each time add 1 over 12 pi. See? So we know that the D is 1 over 12 pi. So half D, 0, 2 times the center 3 plus the last one. So you get these answers and we convert to two significant figures. Alright, so this is the first part as usual. Then next, section asks you to explain with the aid of a sketch, means they need the graph. Why the trapezium rule give an estimate which is greater than the exact answer. So you see. Okay, so this is the graph. The graph for tangent x. Remember, actually the graph for tangent x is like this, right? Okay. Okay, actually the graph for tangent x is like this. Pi over 2 is the asymptote, so it's going up like this. But what we want is until pi over 3 only, 60 degree. Pi over 3 is 60 degree. So they only show this part lah. So you see that from 0 to pi over 3 is here. So the curve is like this. Okay, And as we say, this is concave upwards, right? Because the tangent is increasing. So concave upwards. Alright? So when we want to explain, we have two ways to explain. So please memorize these two sentences. So when you're asking to explain, just write the sentence something like this. Alright? So if follow the textbook, the first one is, they say, from the sketch, the trapezium are each higher than the curve. It's true, right? You see the dashed line? The dashed line is the trapezium, so it's higher than the curve. Hence, this total area is greater than the area under the curve. Alright? Thus, the trapezium rule gives an estimate which is greater than the exact value. You can write like this. Okay, another way we can write is, we are talking about concavity. We use the reason of concavity. And this is the reason that we use more often. You can write like this. The graph is increasing. Increasing, right? But doesn't matter, increase or decrease doesn't matter. The most important thing is concave upwards. Alright, so this graph is concave upwards over the entire range from 0 to pi over 3. Therefore, it is overestimate. See, please copy this one in your textbook. So you have two explanations that you can use. But normally we use the concavity one. Alright? Okay. Then next we will see example 12. Alright, so the question says, use the trapezium rule with 3 ordinates. Find the estimation for the area under the curve y equals sin x from 0 to pi over 2. Then use a sketch of the graph. Determine whether the trapezium rule give overestimate or underestimate. Alright, so this one, they are not given us all the ordinates, right? So we have to calculate d lah. Okay, from 0 to pi over 2. Okay, because 3 ordinates, so n is 2 lah. So the d is pi over 4. Means start from 0, each time add pi over 4. Alright, so only 3 ordinates lah. 2 strips actually. Then calculate sin x using the calculator. Alright, then next, calculate by using trapezium rule, calculate the area. Alright, so half d, 0, 1, and the center one. So center one only one have 1. This one have to times 2. Some mistake here. This 1.414 have to multiply 2. Okay, some mistake here lah. Doesn't matter. You can see. This is y0, this is y2. So this one have to times 2. Alright. But here they forgot lah. So you multiply 2, then you get the answer. Alright, so the estimate area will be 0.95. Then we sketch a graph for sine. Sine, you know, the graph for sine is, the graph for sine is like this, right? This is 2 pi, this is pi. So pi over 2 is here. So they sketch this part only. Alright, so very clear that this is a concave downwards graph. Because the gradient is decreasing from very steep to more horizontal. The gradient of the tangent is decreasing. Therefore, it is concave downwards. Alright, so if concave downwards, so the trapezium will be lower than the curve. You see these two trapezium? Lower than the curve. Hence, the trapezium rule gives us underestimate area. You can talk about trapezium, you can talk about concavity. Or you also can say that the graph is concave downwards. Alright, therefore it is underestimate. Also can. Alright? Yeah, these are the two examples that involve accuracy of the trapezium rule. Alright, okay. So we will see some examples. Alright, so remember, before this, we have discussed question 1. Question 1, using the last video, last lesson, we have discussed question 1C. Using 4 intervals to estimate the area. And they say state with reason whether the answer is overestimate or underestimate. This one we haven't done, right? So since C we have done. And you also have already calculated A and B, right? So you just add the last part. Okay, you just add the last part with the reason. So the C that we have discussed, so it's very clear that it is concave. Again, it is concave downwards, right? So, oh, no, it is concave upwards. Upwards, because decreasing. The tangent from steep to more horizontal. So it is concave downwards. All right, because decreasing, right? The gradient of the tangent decreasing. Concave downwards. So if it is concave downwards, therefore it is overestimate. All right, because the trapezium draw, you can see that the trapezium draw will be higher than the actual area. Okay, so you just say that it is overestimate because the graph is concave upwards over the entire range from 1 to 5. Okay, this is how you write, just like the example 11 that we discussed. So you added for part A and part B that you have done, added the sentence and stated whether it's over or under, with the reason. Okay. So next we are going to discuss some past year question, STPM past year question. Okay, the first question that we are going to discuss will be question number 3. Okay, you can see. I make it smaller. Okay, like this. Can you see? All right. Okay. So we are going to discuss question number 3. STPM 2016. Alright, so the question says, by using the trapezium rule with 5 ordinates, estimate the value for this definite integration, correct to 3 decimal places. 5 ordinates, 3 decimal places, 5 marks. Okay, so it's like this. Okay. Alright, you can see, Let me see. Okay. Alright, the first part, they give us 5 ordinates, right? So remember, if they give you 5 ordinates, so means n plus 1 is 5. So your n is 4 only. Okay, so remember what is ordinates, what is interval and strips. Okay. So if ordinates, n plus 1. So your n is 4. Then we calculate our d. Alright, so you see that the interval given to us is 0 to 1, right? 0 to 1. Therefore, d is 1 minus 0 over 4. Alright, so it's 1 over 4 your d. Okay, then we construct the table. So x start from 0 because it start from 0, right? So 0. So each time add 1 over 4. So add 1 over 4, add 1 over 4, add 1 over 4. So the last one must be same as this upper, we call this upper boundary. Alright. Then again, key in this formula into your calculator. So remember, key in this formula into your calculator. Then each one press, okay, the X, and you get these answers. So remember, just now the question say they want 3 decimal places. So all the answers here we express into 5 decimal places. See? Of course in exam or when you do homework, please give more space okay, give more space so that you can write the whole answers. If the calculator can give you the answer in fraction, then you follow fraction, no need to convert. But if the calculator give you the answer in decimal, then please follow the rules. All right. Then therefore, to integrate this 1 over square root 1 plus x squared, x power 4, sorry, from 0 to 1 is approximate. So remember, must be approximate sign. So use the formula half d, okay, y naught plus the last one, the last y. So all these 3 center we add and times 2. Alright, then the question 1, 3 decimal places, right? So you see the final answer we convert to 3 decimal places. Don't forget to write this. Alright, so a question like this give you 5 marks. So I believe 1 marks will be given, maybe most probably 1 mark will be given for you to draw the D, to get the D. Okay, so 1 mark for the table. Alright, for the x that you given and the y that you given. So I think here this formula might give you 2 marks. So it depends If they give you 1 mark for the x, 1 mark for the y, then formula 1 mark. Alright, if they just give you 1 mark for the table, then maybe here will be 2 marks. You use the trapezium formula correctly and answer 1 mark. See, this is how you can get your 5 marks. It's very simple and easy. Just follow the correct steps. Don't skip anything or write anything else. Okay, so you see that from the past year question, it's more or less the same. 5 marks, 5 marks, 4 marks, 5 marks. Okay, you see here another one, 5 marks. Alright? Okay. Next, I'm going to discuss STPM 2017. Okay, this one. This question. Sorry. So 2017 actually got two parts. Okay, the first part is using the trapezium rule with 6 ordinates. So you see, in STPM, you can see that they like to use ordinates, but doesn't mean that they don't use interval. They give interval also in one of the past year. Okay, but you see, other than that, all are ordinates, 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 ordinates. Okay, these are also ordinates. So with 6 ordinates, find the approximate value for this. Integrate square root x, e half x from 0 to 2. Correct to 3 decimal places. Also 5 marks. Second part actually involved the third chapter, integration. So we will come to this question again when we go to third chapter. This one involves integration. When they use integration to find the exact value, the exact area, then we compare with this one to calculate the error, the percentage of the error. You see? So but now we only discuss part A lah. Alright? So here we are. This is the answer. So you see that 6 ordinates. So given ordinate, so means that if given ordinate is n plus 1, so n plus 1 equals 6, so your n is 5. Then from here you can calculate your d. Alright, d is here from 0 to 2. Alright, so your d is 2 minus 0 over 5. So the d is 2 over 5. Okay, so construct the table. X start from 0 because 0 here, right? N at 2. So start from 0. Each time add 2 over 5, add 2 over 5, add 2 over 5, add 2 over 5. Add another 2 over 5 is 10 over 5. So 10 over 5 is 2 lah. 6 ordinates, right? So you see 1, 2, 3, 4, 5, 6. Okay. Therefore, this definite integration by using trapezium rule is half d. Okay, the y naught here, the last y here. Alright, then center 1, 2, 3, 4. You add center 1, 2, 3, 4 and times 2. Don't forget your approximate sign. Approximate sign, sorry. It must be approximate sign. Alright, so submit all the values and you get the answer. Alright, 3 decimal places. Therefore, you see all the answers here are used 5 decimal places. Then the last answer I convert to 3 decimal places. Must write, must write. So the answer is 3.537. Okay, so also 5 marks. It's more or less they give the marks to the same place. Alright, 5 marks. Okay? Seems like not that difficult, right? Okay, so we will go to one more past year question, which is STPM 2014 repeat paper. This is a question that came out in STPM and it is slightly different compared to others. This one. Alright. They give you a diagram of 2 graphs. One is straight line y equals 3x. One is the curve x square root x squared plus 5. Let's see. Okay. Alright. So they say the curve y equals x square root x squared plus 5 and the straight line y equals 3x in the first quadrant is shown in the diagram. Use the trapezium rule with 4 intervals. You see, this is the only year they use the terms interval. Others more on ordinates, right? Determine the area of the region bounded by the curve and the straight line. They actually want this one. More words, okay? More working, but yet only 5 marks also. Okay, all right, let's see the solution. Okay, so first thing, they don't give us the boundary. Therefore, we have to calculate ourselves. we have to get this intersection point. All right. So this is, let's say, equation 1, equation 2. So the intersection point is solve the simultaneous equation, squaring both sides. All right. Rearrange it. So you see, this is, I have x squared here, I have x squared here, I factorize x squared. So inside is x squared plus 5. This one shift here is minus 9, right? Therefore, x squared equals 0 and x squared minus 4 equals 0. So x equals plus minus 2. So have 3 intersection points. 0, positive 2, negative 2. So 0 is here. Therefore, this one definitely will be positive 2. There will be another intersection point maybe here. Okay, which is at negative 2. But that one is not involved in this question. Can. So from here we get that the intersection, then after we get x is positive 2, then we calculate y. Just sub in here lah, to calculate y. So this intersection point is 2, 6. Here is 2. Here is 6. Alright? So we need to find the intersection point first. Okay, next. As I say, because the question wants this area, right? Alright, so we are going to use the trapezium rule. Okay, let's make it smaller. Okay, so we are going to use the trapezium rule to calculate this area. So we are going to use trapezium rule to calculate this area. Here, this area. The area, so remember, the trapezium rule is calculate the area under the curve. Area under the curve. So it's actually here. The trapezium rule actually calculate this area. Alright? So, can see, so the question say 4 intervals, right? So if given intervals means straight away n equals 4 lah. So we calculate d. So just now we already calculate, right, from 0 to 2. Okay, so d is 2 minus 0 over 4. So d is half. Okay, so x will be start from 0, each time add half and go up to 2. Alright, then use your calculator, key in this formula and press for the y. So I get this. So now this question, my calculator give me in fraction. So I just express in fraction. So we don't have to convert to decimal places. Up to you lah. Alright, if you want to convert to decimal places, then please follow the accuracy that we need to use. Alright, or else just use the actual one. Okay, therefore, the definite integration, integrate x square root x squared plus 5 from 0 to 2 means this green color area using trapezium rule. So half d, why not? The last one. So center 3, add and times 2. Don't forget times 2, you know. Okay, then this is the answer given to us. Because this question they want, this question they actually want what? Hold on, this question they actually want, they never mentioned the accuracy. Okay, you see this question, they never mention the accuracy that they want. So, or as I say, if the question never say, we always use 4 decimal places or 4 significant figures or the minimum 3 significant figures. Okay, the minimum if the question never mentioned. Okay. Alright, so for me, I'm going to use 3 significant figures. Can be decimal, can be significant figures. Okay, up to you. Alright, so since I decide to use 3 significant figures for the final answer, so here I'm using 5 decimal places. Okay. So remember, this 5.317 is the green one. Alright, then to get the shaded region, that's why in exam, you prepare this graph again and you draw all this. Then you don't have to write many sentences to explain. Okay, so this is the area that we want. So we already get this. So the next one will be actually this triangle. See that? This big triangle. Therefore, I written here the area. The area of the triangle. So very simple. Half, base is 2, height is 6, right? So the area of the triangle is 6. So the big one is 6. Therefore, the area of the shaded region here. That's why if in exam, if I sketch the diagram, then I can just say like this. So from the graph is very clear what is the meaning of area of the shaded region. Means the area bounded by the straight line and the curve. Of course, you can write in full sentence lah. All right, will be 6, the triangle minus the green color. Right? Then I convert to 3 significant figures. Okay. Oh, one thing that I forgot. So I also always forgot. So you please remember. Estimate. This one can be actual. So if you want to write here, estimate also can. Alright. This is a question that slightly different compared to others. But yet only given you 5 marks. Okay, more things to calculate, but yet only also 5 marks. Okay. Alright. So we haven't do any question that asks you to calculate the percentage of the error, right? So we will discuss one. Okay, this one is just now we have discussed question 1C, to see whether overestimate or underestimate. Just now we discussed already. So the last question that I'm going to discuss will be question 7. All right, this one. Okay, question 7. Okay, I'll make it bigger. All right, so the question is like this. It is given the definite integral, integrate cos x dx from 0 to pi over 4. All right, so A, you are asking to estimate to 3 significant figures the value of the definite integral by using the trapezium rule with 3 intervals and 6 intervals. Okay, this is part A. So we discuss part A first. Okay, here. As usual, the steps are as usual. 3 intervals, right? So n equals 3. So calculate the d, because from 0 to pi over 4, right? So the d is pi over 12. So construct the table. So x start from 0, each time add 1 over pi over 12, 1 over 12 pi lah, or add another 1 over 12 pi, add another 1 over 12 pi. So after you simplify, it's actually 1 over 4 pi lah. Okay, then calculate your y. So remember this is given pi, but this is cos. So again, either you set your calculator into radian mode, or you have to change this one to degree, because before you press your calculator. But if you change your calculator to radian mode, so remember after you finish, please change back your calculator into degree mode. Okay, so after I get this, though I calculate by using trapezium rule. Half d, okay, y naught, the last y, and center got 2 times 2. So 3 significant figure, 0.703. This is for 3 intervals. Okay, for 6 intervals, n equals 6. So the same step. Alright, same step. Calculate your d, so that your d now become pi over 24. Okay. I make it smaller. Hold on. Okay. Then here. Okay. Make it smaller. Easier to see. Okay. Alright. Okay, here. So for B, the D is pi over 24. So next, same, construct the table. So x start from 0. Each time add 1 over 24 pi, add 1 over 24 pi until the last one. So 1 over 4 pi. Alright? Then again, your calculator. So you get all these answers. Okay, for this step, I am, I don't want to copy this all over again. So I do like this. So I add all these 5 values at the center. Except the first one and the last one. I add all these 5. So I write here sum. Okay, can I write here sum. So I add all these. So I write the answer. So the sum of these 5 answers are this. So I don't have to repeat the step like this lah. Okay. Then therefore, by using trapezium rule, the definite integration can be like this. So half d, the y naught, the last y, and 2 times the sum of the center one. Don't forget to times 2. Alright, then the answer is 0.706 to 3 significant figures. Again, approximate sign. Always mention approximate sign. Alright. Okay, so the first part we have complete. Hold on. Let's show the question. So this one already complete. Okay, let's see what the question want for the second part. Okay, so the second part say calculate the integral exactly as a strip. Means this one we have to use integration. Doesn't matter, it's very simple integration only. Then find the percentage error in each of the estimate value. Also compare this exact value to these two estimate value and calculate the percentage error. Okay, explain using a situable diagram why answer to part A has error. Why these two answer not same as the actual one? Why has error? Okay, so this is part B. Therefore, okay, let's see here. Okay, let me make it smaller again. Okay. All right. Here, like this. Okay. So to integrate cost, very simple. Remember, we have do differentiation of this. We know that differentiate sine x, we get cos x, right? Differentiate sine x, we get cos x. And integration is actually the reverse of differentiation. So if you differentiate sine x, you get cos x. Then when you integrate cos x, you get back sine x. That's it. All right, very simple. Therefore, integrate cos x, you get sine x. All right, then sub the limits here. This definite integration you have done in Form 5, so you should know. Then sub in the upper limit into the integrals minus sub in the lower integral here. So sine 0 is 0. So sine pi over 4 is 0.0707. All three significant figures. Again, forgot. Okay, so much, right? So by using the definite integration, this is the actual or exact areas under the curve. Okay, now we calculate the percentage error. All right, the percentage error. So you see here. Can see? Okay. Can see? All right, so the first one, when we divided it into 3 intervals, the answer that we get is 0.703. So to calculate the percentage error, the actual one must be the denominator. The actual one is this one. All right, since this is bigger than this, so we use 0.70 minus this one. These two. Which one minus which one? It depends which one bigger lah, or which value bigger lah. But the denominator must be the actual one, the exact answer. So this is the exact answer that we get from integration. All right. So since this is bigger than this, so we use 0.703 minus 0.703, 73. Okay. Then multiply with 100%. All right. So the answer is 0.566%. So the difference, percentage error means the difference between the answer that we get from using Trapezium Rule compared to the answer that we get from the actual integration. All right, it's only 0.566% different. All right, so the second answer, we even divide into more intervals. So remember, we learned the concept. When we divide it into more intervals, the answer is supposed more correct, more close to the actual answer, right? Then it's true, you see? If we divide it into 6 intervals, the answer we get is 0.706. It's even closer compared to the actual one, compared to the 3 intervals, you see? So this question actually explains this concept. All right, therefore, again, the percentage error will be, again, denominator must be the exact one. Okay, then compare these two. This is bigger, so we use this one minus this one. Because this is underestimate. If you get overestimate, means if this answer bigger than the actual one, then you use this one minus this one. We always use the bigger minus the smaller for the numerator part. But denominator always must be the actual one, or the exact answer. Then when we change into percentage, then it's 0.141% only. The difference only is 0.141%. So compared to 3 intervals, it's 0.5%, but this one is 0.1. So it's closer, right? The error is smaller, right? Okay. Then next, excuse me. They want us to use one diagram, right? To use a diagram, or to explain the why the error happened. Why this error? Why got different? Why got error? Means they actually want you to say why it's underestimate or overestimate. So we draw the graph for cos x. So you know that the graph for cos x is actually like this, right? Oh, 0 to 2 pi. Correct? So this is pi. But what we want is 0 to pi over 2 only. So here. So we only draw this part actually. Okay? Okay? But the limits given to us is 0 to pi over 4. The center. So what we want is actually this part. Okay? So the definite integration, this one, when we integrate cos x from 0 to pi over 4, is actually calculate the area under the curve for the red color that I shaded one. Okay, so by using the diagram, then we explain now. So the error occurs, why got error, right? The error occurs, and we know that it's underestimate. Why underestimate? Very simple lah. This is the actual one. The one that we get from trapezium rule is smaller, so underestimate lah. So the error occurs, which is underestimate, is because the graph is concave downwards. See, concave downwards. The gradient from no, it's concave upwards, sorry, because the gradient is increasing, right, from more horizontal to more steep, right? Sorry, I made the mistake. Okay, so it's concave upwards. All right, the graph is concave upwards. Yeah. The tangent that we draw is above the this one on top, right? Hold on, now let me double check. a little bit confusing. Let me double check. This is actually concave. Sorry, it's concave downwards. Yeah, concave downwards. Sorry. Concave downwards, Okay, from here, yeah, more steep. Yeah, it's concave downwards, correct. Sorry, concave downwards. Yeah, let me double check again. Yeah, concave downwards. Okay, it's correct, concave downwards. Very simple lah. Remember I said if I draw the tangent, you see, if I draw the tangent is above the curve. If the tangent is above the curve, then it's got concave downwards. All right. So the graph is concave downwards over the range x equals 0 to pi over 4. Therefore, this is the reason, because it is concave downwards. Therefore, the error occurs, means it is underestimate. All right. Or another sentence you can use is because the trapezium are each lower than the curve. If you draw the trapezium, it's lower, right? It's lower than the curve. All right. So these are the reasons that you can use by using the diagram. Okay. All right. So we have complete chapter 6. We have fully complete chapter 6. Therefore, yes, throughout this weekend, please complete this exercise. Your homework will be exercise 6.3 in your textbook, page 189. Please complete question 3, 4, 5. 1 and 2 you have done last lesson. And for past year question, in your notes, all right, in your notes, example 6.2.2, please complete question 4, which is STPM 2014, question 5, STPM 2006, and question 6, STPM 2017 repeat paper. And one more question. You remember the set past year question that I give it to you? Yeah. One more question is STPM 2019 repeat paper, question 6. All these are involved trapezium rule. Okay, so please complete this. All right. And the question that you need to upload to your folder will be this one. Okay, so please upload this question. Scan it and upload into the folder that you sent to me. Okay, yet they are not all of you send me the link of the folder that you create. Please, those who haven't. All right, so by tomorrow, please send me the link of the Google Drive. Sorry, the Google Drive that you have created. And make sure in the Google Drive, you already have 2 homeworks that you should pass up. This is the 3rd one already. All right, so I hope everyone complete your homework. As I say, follow the time. Don't delay, or else it will accumulate and become more and more and more. All right, so okay, thank you class. So we have complete chapter 6.